Hello, everyone. This week we're going to talk or take a look at text mining and natural language processing. In the Foreman book, chapter 3 talks about Bayesian analysis, which is essentially, and he goes into a lot of detail about using a probability theory to identify the frequency of words or the likelihood that a word is going to show up, whether it be from one of his sort of application-related tweets or it's some other tweet. And that's all fine. And I think his initial stuff in his early chapter is fairly useful. And it's kind of cool to see what he does with it in Excel. But I'm not going to have you guys get too wrapped around the axle on the probability theory stuff. We'll talk about that later, actually. Just take a look at his chapter real quick. The other thing that is relevant here is your second chapter in the big data book is called Messy. And you're going to see Messy in this presentation. We're going to talk a little bit about why text mining and text processing and natural language processing is a very big challenge in this field because it accounts for a vast majority of what we process on a day-to-day basis, and it's messy and it's tough to look through to actually make any meaning out of. So that's what this presentation is really going to be about. Last week we took a look at clustering algorithms, and we looked at the k-means, k-medians, and hierarchical clustering algorithms. We can actually use clustering algorithms with language, but we have to do a whole lot of processing on it first. When we did the example in the Foreman book where he used his wine customers and he created a 4-means or 5-means k-median cluster or k-means cluster, he had structured data. It was structured numeric data, and basically he used a pivot table to turn that into structured numeric data. That's great. Most clustering algorithms utilize structured data. But if we don't have structured data, then there's something we have to do to the data first in order to be able to make it useful. And that's what we're going to talk about today. As I've indicated, text mining is a big deal in the field of data science. And you can see why. 80 to 90% of all of the corporate data that we store or use is in some kind of unstructured format. And unstructured formatted data is doubling in size every 18 months. So tapping into these information sources is not an option. We have to do it. We have to be able to track what we're doing, and not everything fits nicely into an Excel spreadsheet or into an Oracle database. So we're left with the need to really refine skills and tools around text mining. And text mining is really a semi-automated process of extracting knowledge from these unstructured data sources, or otherwise known as text data mining or knowledge discovery in textual databases. That's just a whole lot of words of basically being able to say, how do we get a bunch of documents or a bunch of other text sources and peruse them to find out what meaning we can extract from that information? What patterns, what information can we get when the information is just really huge? It's good to look at data mining versus text mining. Data mining is a little bit of what we did last week when we were actually looking at clustering. We had nice structured data sets. Data mining and text mining are both really trying to extract information out of large collections of information or big data. Both are seeking novel and useful patterns that we can use. We try to make sure that both are a semi-automated process. Certainly we don't want people to manually be looking through documents. It would be at some point impossible for them to find anything useful. So we need semi-automated processes to look through non-structured data in order to be able to find what we're looking for. The difference is the nature of the data. Structured data versus unstructured data. Structured data is something like a database or an Excel spreadsheet or something where it's nice and clean. We know exactly how big the fields are. We know exactly how many rows we have and how many columns we have. That's structured data, and that's not that much of the data that we actually encounter. The unstructured data are things like Word documents, PDF files, text excerpts, XML files, and so on. Things that are messy, that have to be cleaned up and processed and put into a structured form before we can use it. So text mining first imposes structure on the data and then mine the structured data. That's the process that you have to go through in order to get meaning out of unstructured data. Some of the more common uses of text mining include applications in text-rich environments. For example, law offices and courts and the like produce briefs and drafts and other legal documents that have to sometimes be mined when you're looking for legal precedent. Academic research, when you're producing research and you're writing articles and you want to find anything that is useful or relevant. I don't know if you've had this experience, but looking for research articles based on what you can find in the abstract is sometimes really a frustrating experience. Finance for quarterly reports, medicine for discharge summaries, biology for molecular interactions, technology, things like patent files, and marketing, customer comments, etc. All these are really text-based data sources where text mining could really be useful. A real clear application for text mining and the application of text mining is in electronic communication records, for example, email. Using text mining, we're able to identify and match on certain patterns that will allow us to filter out spam, or that will allow us to prioritize emails that are especially important, or that can even actually read an email, identify what's in the email, and generate an appropriate automatic response back to the sender based on what the sender has included. Some of the important concepts that are related to text mining are as follows. First of all, information extraction. How do we get what we need? How do we pull out what we need, whether it be a collection of text documents or excerpts or something else? We're also going to be topic tracking. We're going to identify areas or topics that we want to be able to track in our data set. Can we, once we've processed the data, come up to some level of summarization or categorization where we can actually identify, here's what we can make out of 10,000 documents, here's what we can summarize, or what categories we can build of important terms that are found. When we identify important terms and are able to put the data into a structured format, we can apply clustering algorithms to identify certain, potentially of the 10,000 documents I just referred to, maybe there are 250 of those that have very similar content. Or there's three categories in a k-means cluster. Concept linking would be able to sort of build associations between things that we've pulled out. And then ultimately what we're trying to get to is question answering. We are going to go get 10,000 documents and we're going to search for those 10,000 documents to try to identify some pattern or something to answer some question or to fulfill some need. And that's ultimately what we're doing here, whether it's structured data or unstructured data. Some key text mining terminology include things like unstructured or semi-structured data, which we've already talked about. Unstructured data is data that does not fit into a nice clean database or Excel spreadsheet structure. And it may not even fit into a nice clean text structure. You may have documents that are PDFs, documents that are Word documents, just flat text files. Those all have to be organized and structured in a similar common way. Semi-structured could be things like, what if they are all tweets, or what if they are all text files, or something like that. At least we have some structure that we can expect. We have some idea of the number of words that are going to be in each one. Corpus and corpora is actually the plural of corpus, is the organization of data into a particular unit, a particular style or unit. And so we identify a piece of text or a piece of information, and that becomes sort of a semi-structure, if you will, a corpus of how we organize and hold the data. Clearly, there are many terms in the data, so we're going to want to understand what makes a term and how do we organize the term. If you look at Foreman's process in his book, he has this whole extraction of words, removing all the punctuation and all the spaces to identify what actually makes a term. Stop words and include words would be words that you specifically want to either eliminate or include. And remove or whatever. Synonyms, polysemes, synonyms are associations of words that basically mean the same thing, obviously. And then tokenizing is where you can identify, once you go through a data set and identify our text set and you identify what all of the terms are, then you can turn those into tokens and you can start counting those tokens. That becomes a very useful process for identifying kind of what are the most common words in a text file or a text set, and what does that actually mean. A few more useful terms in regards to data or text mining and text processing is a term dictionary. We identified what terms are, but now we might need to identify what they mean and how they're used in the document, and that can become important. Obviously, word frequency, we're counting the number of times a word occurs. So the more times the word occurs, the more time it may have, or the larger impact it may have on the overall process of the text. A term by document matrix, which we'll talk about in a little bit when we go through the workflow of how to process text, is how you basically build up a tool that allows you to build up and track the occurrence of each of your terms. So you've identified your terms, you know what your terms mean, and now you're really sort of identifying a way of being able to note how many times does this particular term show up in my data collection. And then single value decomposition, which we won't talk about a whole lot, but basically it's a process of going through and identifying the level of variability that happens in your word set, in your data set, on your text files, and being able to construct entities that basically represent some percentage of that variability, and then be able to sort of say, you know, these, in order to account for 90% of the variability in my text files, I have to construct 20 components. The higher number of components, the higher the variability in your text file is basically what that means. And don't worry about getting your mind wrapped around that. That's a statistical process that is far more complex than what we're going to talk about in this class. Something that is very strongly related to text processing and text mining is the concept of natural language processing. And natural language processing has been a gigantic problem for computer scientists for years, for decades really actually. And it gets to this whole concept of how can you get a computer that is actually going to be able to input text or conversations or some other communication from basically from humans or from other sources and be able to make sense out of it. There's a couple methods. The old approach is what's called bag of words. This is what Foreman uses in his chapter 3 example. And this is essentially identifying a group of words and looking through the text to identify if you can find any of those words. It's as simple as it gets. It's a basic match. And also Foreman's process of going through all that probability theory is what's the probability that any of these words are likely to show up given that he's either dealing with a tweet or he's dealing with some other form. But it's basically just a mix and match. Can I identify actual words based on a list of words I'm inputting? The new approach is to actually go a step further, and that is I'm not just going to identify words, but I'm going to identify words and how they flow together. And I'm going to be able to identify how a word is defined based on its use and its context. It's beginning to get us to a place where we're starting to understand better, or the machine can understand better, what it is we're actually saying, not just the words we're saying, but the meaning behind them. So natural language processing is a very important concept in text mining, obviously, because it's allowing us to sort of identify not just the words, but what the words mean. It's a huge subfield in artificial intelligence. You're probably running into natural language processing more often than you think, but it is a growing and burgeoning field. One of the key challenges of natural language processing is understanding, is the concept of understanding. And this gets back to whether or not we just understand the actual word, such as the word book, or can we understand why the originator of the communication used the word book, how the word book was being used, and what sort of covert or subcontextual meaning that the use of that word has. So much of language, of our communication, of what we do, as you're fully aware, is not based on the words that we actually say. It's based on the context, how we use the words, the inflection of our voice, how the word is based, how the word is buried basically in the text. And so it's really difficult in natural language processing for computers to really truly understand what we're talking about because they don't understand the context, they don't understand sort of the subtleties of the language, and it just requires that a computer have a very strong context, very strong knowledge of a particular topic. So the question remains, and this was a question that was being asked in the 1980s when the whole concept of artificial intelligence was first coming about. They were talking about, will a computer ever really be able to understand language the way that humans do? For natural language processing, this begins to sort of expose the weaknesses of text processing and text understanding by computers, simply because so much of what they do is still based on just identification of words, not the meaning, not the context, and not the understanding. Here's another slide that shows sort of the challenges in natural language processing. And this is kind of what I've talked about in the previous slide, but challenges in natural language processing include the ability to sort of identify the part of speech, what we're actually looking at, and how we're breaking the speech up. Again, text segmentation. How do we break up the text that we're getting? Word sense disambiguation. What does it mean? What does the word mean? And this gets back to this whole concept of it being sort of arbitrary use of words that are sometimes vague and ambiguous. Syntax ambiguity. Again, how are we using the words? imperfect or irregular input, when the words are either spelled differently, abbreviated, in not spelled well, or some other issue that causes variability in how the words are brought together, but they essentially mean the same thing. And then speech acts, if the machine is taking in information, such as your iPhone or whatever is taking in information, how does it learn your voice? How does it learn your words? And how does it learn when you say certain phrases that they're supposed to mean one thing and the autocorrect shouldn't actually correct it? So all this stuff is just, this is just natural language processing, not even to mention the whole concept of breaking into the idea of understanding what the text even means. The dream of the artificial intelligence community is to have algorithms that are capable of automatically reading and obtaining knowledge from text. That is really kind of getting to the point of understanding. So now that we have some idea of text mining and what we would use text mining for, and also its relationship to natural language processing, um, here are some examples of why you would use text mining. First one is marketing applications. So we get information in from customers. These can be comment cards or comments or other text-based formats, other text-based communications. It could be a survey of other vendors who are actually putting out products that are similar to yours. It could be comments from customers when you're speaking to them that are typed into a CRM system. We would need to process through all of that information in order to be able to make useful sense out of it. Security applications, this is for basically deception detection or fraud detection. What are we looking for here? What can the algorithms flag that seem to be out of the norm, or is there some way of being able to identify email scams? And what terms of text are we looking at in order to do that? In medicine and biology, we can look through the literature that's out there. For example, there's a process where you identify a gene and then you identify as much information about it as you can, but there are so many genes, there's so many that for which we don't really have a definition. So if you identify a gene and you identify kind of the location of it on the chromosome and be able to process certain information in it, can you search through literature to find information about that gene in order to understand what its function is, or if it even has a function? And then, of course, academic applications, similar to the medicine application, being able to sort of identify a concept and go out and stream through or look through a ton of research articles that have been put out. There's more stuff being put out every day that actually will give you information about your particular topic and what is the latest research that has been done on that topic. Here's a simple little model that will show you kind of the process of text mining. If you look over there on the left, you'll see that one of the inputs is the unstructured data and the structured data. Unstructured data, of course, coming in from various forms, text, Word document, PDF, those kinds of things. And structured data, which is a little bit more structured, is going to come from a database. And the reason why that's structured is because we know exactly where to find it. And the data, in order for it to be able to go into the database, has to conform to certain field parameters that have been specified. At the top, we have other inputs that impact the process of extracting knowledge, and that is software and hardware limitations. Keep in mind that if you're working on a PC, you're probably not going to be able to process 10,000 documents. So you need to work on a much larger server and be able to get access to that. And those limitations can be pretty limiting. And then privacy issues. What are the implications of extracting information from maybe potentially confidential sources? And how do we make sure that those confidential sources are protected? And then the other thing is linguistic limitations. Not everything is in English, and even with English, not everything is in the same kind of English. So while the Canadians sound a lot like us, they spell things a lot differently than we do, and they speak, even formulate their sentences sometimes differently than we do. And certainly the Brits and the Australians do as well. So how do we account for that? Even though it's the same language, it's not done linguistically in the same way. From the bottom, we've got basically kind of your inputs are going to be your domain expertise and your tools and techniques. What tools are available for you to be able to extract data out of a text set, and how well do you know the field? How well do you have access to people who know this field pretty well to be able to help you with that? All of those inputs go into the process of extracting knowledge from available data sources, and ideally out comes a context-specific knowledge source or context-specific knowledge answer or result or something like that you're actually able to get out of this process because you've been able to successfully interact with and use all of the inputs. This slide shows a linear representation of the text mining process, and it's not that different from just normal structured data mining process, but it has some nuances that make it stand out. In step one, task number one, what we're really doing is we're establishing the corpus. We're collecting and organizing the domain-specific unstructured data. So that is going out and gathering the data and then determining the format that it will actually be put in. What is the structure? What is the input, and how does it look? Then we move on to the second step, and the second step is to really sort of identify or process or clean up the data, and then identify what's in it. And then we move on to the third step, and the third step is once we've sort of cleaned up the data and organized it and built sort of this matrix, which we'll talk about more in a bit, what do we do with the data to actually make sense out of it? What knowledge can we derive from it? There's a fourth task, and the fourth task would be to actually represent the data, represent or present the data. We won't talk about that too much because that's essentially another whole side of data visualization and reporting. But that is a very key fourth step. If you can't present what you found in a very clear and understandable way, then all of the first three steps were for nothing. And this is a little bit more about the data analysis lifecycle. And you'll see various forms of this, but the simplest way to look at this is data analysis, whether it be text or data or whatever, has 4 steps. And the first step is to get the data. And in a text context, getting the data is to identify the documents or the text files or whatever it is you're going to be using. That's your input. The second step is to clean and organize the data. When we were doing R means clustering, we had to do some work on that file, or the foreman did the work for us actually, and showed us how we can sort of process that data a little bit in order to build the pivot table, and then to use solver in order to identify the closest cluster means, those kinds of things. Well, in text, it's a much bigger deal to actually clean and organize the data. So what you have to do is figure out how you're going to represent the data, and then go through the data set and sort of clear out all the clutter and clear out all the unuseful stuff, and then identify the stuff that actually is useful. So in this case, you might look through a set of Word docs and identify all of the key terms that you want, but also have to do a whole lot of processing on the data to throw away all the junk that you don't want. So this is a big deal, and this is where a lot of data processing and analysis can fail because the data aren't organized and processed in a clean way. Then we make meaning out of it. Once we've got a clean set of data, we can make some meaning out of it. So in the case of the k-means clustering, we could identify, which customers had purchasing patterns similar to other customers. But in this particular case, in a text file, if we're looking for specific terms or specific information, we can use what we derived out of step 2 and make meaning out of it in step 3. And then in the previous slide, I referred to the fact that there's a step 4, and that is to be able to present the findings. So once we've made some meaning out of the data set, how do we then present the findings to those who care, to those who need to know, or in a way that actually makes it useful for us? So let's go through these steps, the first 3 steps, in a little more detail in a text mining context. So the first step is to establish the corpus. That is to collect all relevant unstructured data, whether it be text documents, XML files, emails, web pages, short notes, voice recordings, whatever it is we need to parse through or look through in order to be able to mine out what we need. Then we're going to digitize or standardize the collection. The goal here is to put it into a structure that is similar or common, so that the process that we pull or that we run on it can run on one sort of source, one sort of formatted source. Then place the collection in a common place. We identify where we're going to put it, what server we're going to put it on, and what format we're going to save it in. In step 2, we do 2 things really. We clean up the data, throw away all the junk that we don't care about, and then we identify ways of being able to figure out where the terms are that we do care about. So in this example, there's a text sort of matrix that's created, a text by document matrix. And you can see that the documents are listed over there on the vertical axis on the left-hand side, and then the specific text terms actually that we're looking for are listed across the top. And it, obviously it goes on and on because this is would be a much bigger data set than just 6 documents. But what we're doing is we're identifying the instance of where these particular terms are found in these particular documents. Again, this is one format or one way of being able to track where your terms are. This would be very much like the bag of words example, because we're just simply doing text matching in the document. We're not even thinking about making any meaning out of this, but it could be a way to organize terms so that we could then run another algorithm on those terms to see if we can make any meaning out of them. During step 2, we are probably going to, once we build our matrix, we're probably going to go through the matrix and actually clean it up a bit, decide what it is we want to track. Should all terms be included? And ideally, there's going to be a process, an algorithm of sorts that's going to go through and make these decisions for you. So you've already identified and put as inputs, what are your stop words, what are your include words? Are there any sort of synonyms or homonyms that you want to actually have that algorithm take into consideration? For example, I'm going to be looking for a particular word, and here are all the synonyms that look just like that word. So find those too. And then stemming. Stemming is basically the process of identifying a word such as fishing. And the stem of that word is fish. And so there may be various forms of fishing, and you want to actually identify all of those and break those down to its most simple form. So the algorithm will do all this, and then the algorithm will also go through, and you will have fed this information in as well. But how is it that you want to represent the data once you've processed it? Do you want to have it in rows? Do you want to have binary frequencies, which basically show does the word show up or not? Do you want to represent that as a logarithmic value, like Foreman does in his example, simply because that's the best way to represent the numbers? So these decisions are all part of the processing part of how the data should be processed when it comes from a text source. Once we've built our matrix and we've cleaned it up a bit and determined what we're going to use, what we're going to keep, and what we're going to throw away, now we can actually take steps to utilize that information. So we're going to look through the matrix that we've created or the data source that we've built, and we're going to extract patterns or try to sort of create knowledge. So what we can do is we can classify. We can look for text categorization or classifications and see if we can identify where those are or how those are being represented. We can cluster. We can actually build clusters of the text terms and identify which documents actually contain those, which documents don't, or are there sources of text that are very similar to other sources of text, or do they break into a certain number of groups? We can build associations. We can also do trend analysis. So for example, our older documents didn't have very many of these terms, but our newer documents do have these terms. So what does that mean and what's happened there? Those various things that we can run on this process to actually make use out of the data. And as I've indicated, the last step is being able to present your findings to whoever you're wanting to present your findings to. So you went out and you processed a whole bunch of text and you identified the terms that you wanted and you put a bunch of rules into the algorithm and you processed all this text and now you found some great information. So now what has to happen is what does it mean and who cares and all that. We're going to actually cover this later, so I'm not going to go into a whole lot of detail about it here, but it kind of breaks off from the data science and gets into a whole different field, and that is data visualization. So we'll talk about that later on. As you might imagine, with such a rapidly growing field, there are some players out there who've actually produced some tools that will allow you to do various forms of text mining. And on the commercial side, you have big players like SPSS and SAS who are kind of on the higher end as far as expensive, probably higher end as far as functionality as well. But there's a couple other there too that will allow you to take in data sets and be able to sort of make meaning of them. There are some free tools out there as well. There would be various tools that are limited probably in different ways, but they're out there, and there's a couple of them listed right there. The example that Foreman gives us in his textbook uses Excel, and that's great, but it's going to be fairly limited in the sense that your input's going to have to be so similarly structured. The example he gives us looks at tweets, and tweets, as we know, are of a certain length. They can be no longer than 140 characters, and they're formatted fairly similarly. So using Excel will get you only so far. These other tools will do a much better job. Okay, and that's basically an overview of text mining and natural language processing. And if you want to take a look at, again, if you want to take a look at Foreman, he gives you one example, but go ahead and do read the chapter Messy. It's called Messy for a very obvious reason, as it talks about sort of unstructured data sets and how so much of what's coming to us these days falls into that realm.